Let's take a look at section 6.4, factoring trinomials of the form ax squared plus bx plus c using the AC method for factoring trinomials. The grouping or expansion method is also known as the AC method, and it's used as an alternative to the trial and error method for factoring trinomials. So when you factor these trinomials, ax squared plus bx plus c, and you use this method, it only makes sense to use it if a is not 1. You can use it when a is 1, but it's an unnecessary thing to do. So in the AC method for factoring, you multiply a times c, and you find two integers, n1 and n2, whose product is AC and whose sum is b. So n1 times n2 needs to equal AC, and n1 plus n2 needs to equal b. If no such pair of integers exists, the trinomial is prime. So what we do once we find these two integers is we use them to rewrite the middle term as the sum of two terms. So instead of writing the middle term as bx, we will write it as n1x plus n2x. And then we're going to factor by grouping. And then we're going to check our answers by multiplying out the factored form. The check is optional unless you are specifically asked to show it. So if we want to use the 5-step process to factor 5x squared minus 2x minus 7, we have to recognize that a is 5. That's always the coefficient of x squared. B is negative 2. That's the coefficient of x. And c is our constant, which in this case is negative 7. So our product that we're looking for is actually a times c, which is 5 times negative 7, which is negative 35. And the sum we're looking for the two numbers to give is negative 2. This is real unusual because a times b, negative 7 times 5, actually gives us, so right off the bat, a times c gives us the two numbers that we were looking for. So we actually found the two numbers just by realizing a and c actually provided those numbers. That's unusual. Usually that's not the case. So we're going to rewrite our middle term as the sum of two terms, and we're going to use the integers that we just found to do that. So we don't change the first term, but instead of writing the middle term as negative 2x, we're going to write the middle term as negative 7x. And I'm going to color code this. So instead of writing that middle term as negative 2x, we're going to write it as negative 7x plus 5x. And then we're not going to change that first and third term. We're going to leave those as we had already written them and as they were written in the presentation of the problem. And now we're going to factor by grouping. So we notice that the GCF of 5x squared and negative 7x is simply x. So x multiplies times 5x to give 5x squared, and x multiplies by negative 7 to give negative 7x. Now, whatever the last two terms are, we need to factor a GCF out of them that also multiplies times 5x minus 7. But notice the last two terms are 5x minus 7. So that means we're multiplying that by positive 1. The common binomial factor is 5x minus 7. And we're multiplying that in first position. So here we're using the distributive property in reverse. So here 5x minus 7 was multiplied by x. So that's why this x is here. Here 5x minus 7 is multiplied by plus 1. So we write a plus 1 there. And that is our factorization. And you can check this if you wanted to see if it really gave you the original polynomial. 5x times x is 5x squared. 5x times positive 1 is positive 5x. Negative 7 times x is negative 7x. Negative 7 times positive 1 is negative 7. And if we combine the like terms, we see that we do get the original polynomial. So that does check out. All right, so here we want to factor 5x squared minus 2xy minus 7y squared using the AC method. Well, we see the coefficients are the exact same coefficients. So everything is going to work as it did before. A times C is 5 times negative 7, which is negative 35. And I'm looking for two numbers that multiply to give that. And those same two integers, they actually have to be integers, have to add to give B. And we see the numbers are negative 7 and 5. We can multiply and add in any order. So we could have had 5 times negative 7 and 5 plus negative 7. All right, so we rewrite the polynomial. So instead of writing 5x squared minus 2xy minus 7y squared, we would write 5x squared minus 7xy. So notice the variable, the two numbers I found, the two integers I found are my coefficients. The variables remain, the variable of variables remain as they were on the middle term before you factored it. So notice now my middle terms are xy terms. And I factor out an x from both of these, and I get x from the first two terms, x times 5x minus 7y. Now, whatever GCF I pull out of the last two terms, it's got to also multiply by 5x minus 7y. So I'm really asking myself, what multiplies times 5x to give 5xy? And what multiplies by negative 7y to give negative 7y squared? And it turns out the result is a positive y. So this factors into 5x minus 7y times x plus y. And that is my final result. So whatever variable or variables are on the middle term, the original middle term of the polynomial you're factoring, that is the variable or variables that are on the two terms when you rewrite that middle term as two terms. And of course, you can always check this by multiplying through. So 5x times x is 5x squared. 5x times y is positive 5xy. Negative 7y times x is negative 7xy. Negative 7y times positive y is negative 7y squared. And so now I see that that does check out and give me my original polynomial. And for some reason I copied this problem over a second time. That was an accident. Let's factor 15x squared y minus 6xy squared minus 21y cubed using the AC method. Now, whenever you're factoring, you should always factor out. You should look to see if the entire expression has a greatest common factor that can be factored out first. So I notice that 3 divides evenly into 15, 6, and 21. So this GCF is going to have a 3 in it. I notice all of the terms have a y in them. And the lowest power to which y ever appeared was 1. So y to the first power is also part of the GCF. So 3y needs to multiply by 5x squared to give me that first term. 3y needs to multiply by negative 2xy to give me the middle term. And 3y needs to multiply by negative 7y squared to give me the third term. And you recognize that the polynomial in the parenthesis is the one that we just factored. So we can write this as 5x minus 7y times x plus y. And since we had already factored 5x squared minus 2xy minus 7y squared, we went through that process and we just copy our results from the previous problem here. All right, and so this is the worksheet for section 6.4.